good to know. Yeah, we also put the slides on the before the slides on the website. No. Okay.
Hey, it's done.
Well, see.
Have you ever really done any summarization?
Me?
Yeah.
No.
You did a while ago, right? Years, decades. Pre-Rouge score. No.
What are you asking?
Well, I was, teaching it today, which meant I had to learn about summarization and everything.
Yes.
And I realized what just total crap the Rouge metric is. I feel bad about it because it's out of here. But it was created entirely so it's like this doesn't mean anything to you. It's like AQWV or something. It's like if we use that, then going forward for all IR. It was like a metric that was constructed very specifically for duck, it seems. And isn't even terribly well motivated for duck as far as I can tell. And certainly isn't useful now. It was it only really makes sense if you're told generate a summary that is 50 words long, generate a summary that is 100 words long, which I don't think we do now, as far as I can tell. And it's I don't know. We just keep on scoring with it because other things score, and we want to compare against.
A lot easier to give a hint and then they pick it. And when
I'm just kind of aghast.
The hint is much less impressive. So there's some notion of it's like why is it changing the whole area?
By the way, this is Sally. Sally.
Hi, nice to meet you. I'm a faculty at CS. I'm a faculty at
Ah, cool.
Have you been?
He was actually busy, and so I just talked to him.
So what did you give Peter $18 yet?
I did.
So, thank you for pointing that out. I would have just not even thought about it.
Well, German people can be very picky. No, it's kind of oversight.
I just vaguely remember.
Glad to see that people are keeping the ships.
I think we had dinner at a Syrian restaurant. It's CMU, like 6 years ago.
Oh wow.
Where's your order?
Have you?
For too many other people.
I mean, I've been visiting. I've been visiting SIMU conferences, but
I've never been a visitor. Can't believe I've made it this long.
I've been to excuse.
Missing one.
I recently
We have a little bit of an LP group there. Yes.
So yes, I visited there.
Okay.
For a few days.
So, could I start? Yeah, but I think the recording is not.
Oh, is it? Oh, yeah.
So, Waleed Ammar is a senior research scientist at the Allen Institute for Artificial Intelligence, where he leads the research efforts in the thematic scholar project. He is interested in developing NLP models with practical applications, especially in the scientific and medical domains and other data-constrained scenarios. Prior to his PhD at Carnegie Mellon University, Waleed was an engineer at the Machine Translation Group at MSR, a web developer at East-Based Technologies, and a teaching assistant at Alexandria University. Waleed co-hosts the NLP Highlight podcast with Matt Gardner. So welcome on, please.
It's a pleasure to be here. Thank you very much for inviting me. We're going to talk about something I'm really passionate about. When I think about the work that we're doing in Semantic Scholar, I think of it this way. We have this huge literature that we're trying to use and build on without kind of without thinking of it as an enemy, because oftentimes.
Was that your kid?
No. So information overload is something that we all are very familiar with on a day-to-day basis in many domains, right? So we can't read everything that we are interested in reading. And think about this in the scientific literature, it affects our day-to-day job, right? So while I was preparing this talk, I read this tweet by William Wang, who's talking about inability to look at, just like scan all the papers that are published at the top tier conferences in his domain. And that's something I think many of us associate with. So not just like students or people who are just starting in the field. So if you look at this picture, this shows the number of articles being published in the medical domain over the years. And not just the magnitude is increasing, but also the rate of publication is increasing. And there are many things to ponder about when we're looking at this picture. Oh, by the way, the different curves correspond to different languages, and the largest one is English. And this one is also interesting. It's Chinese, and it continues to increase this way. So Chinese also is a very interesting language when we think about the scientific literature.
Why does it say Index 10?
So the numbers for English are 10 times as much as the scale.
So it's okay.
Yeah. But I think
ing over 10.
Sorry?
Shouldn't I say ing over 10?
I don't know. I didn't really make this graph myself, but I appreciate the effort that Alexander Don put into it. But it does just draw the point that we're trying to make here. So one of the things that I find fascinating about this is I'm not sure to what extent this corresponds to actual scientific progress as opposed to what I call paper inflation. So if you think about a paper as a currency, you need this much paper to apply for that job. Or of course, this is simplification because not all the papers are the same. But I wonder if how much of this is paper inflation, the value of individual papers being lower over time on average. Another thing that I'm curious about is like how to make sure that the progress we do in science translates into progress for society. So the tricky thing here is that the values of society are much harder to change. So when you think about vaccination, for example, a lot of people are resistant to it because it's against their values. And in other cases, we adopt the science very fast before we have enough time or we vet it enough. So things about assuming that the data that we provide to a service like Facebook will be kept private is kind of a strong assumption. And yeah, so I think there's a lot of things to ponder about here. But the main focus of this talk would be about how does this information overload affect us as researchers? So one thing, I'm gonna mention a few things that we found by talking to researchers that they're suffering from because of this information overload. To be specific about what problems we're trying to address. But I guess in order to make this more interactive, I'd like to also hear from you, and maybe there's something that we haven't been thinking about. So how do you feel like this problem, the information overload in scientific literature, affected you personally, and your ability to do your job?
I had a paper rejected, and I was really disappointed, and I wish fewer people would submit papers so that more of my papers. It's really sad.
I think the solution for this would be reduce the funding, right? So yeah, the president is doing a good job to address this problem.
I think now we rely more on Twitter to find good papers. You show up somehow there. It's good paper.
Oh yeah, I think relying on other people to do the scanning and find out which papers, and I think that's one way to do it. But also, some places have a stronger PR power force that they can advertise their own things. So Google research is very good at promoting the research that they do, and yeah, I think it's a reasonable thing to do, but also creates some inequality in the way we consume paper.
I think more seriously, so that, and also there's people who are I've known or who come from universities that are fairly well respected, and you can't scan the entire proceedings very easily anymore. But an individual person, for example, still, although some of them can produce quite a lot of papers at one time, they can still produce not as many papers in one conference that you can look at. So I'm more inclined to, it actually sort of undoes whatever kind of author bias preventing aspect of a paper getting, sorry, this is complicated. I would generally review, say, the entire, let's say, machine translation track for a conference and look at them. If the paper titles look interesting, I'll go to them. And at this point, it's there's too much, so I'm just going to look for people's names. Oh, I know them, they could do good work. And I'm not going to even read the other papers. And I may not even believe them because, oh, there's too many, the acceptance rate is too chaotic, certainly on archive. If this person has no name, I can't even trust what they're saying. And so that, sort of undoes any kind of equality that we think that over publication or the ease of publication has given us.
But that's exactly the problem, right? If you have this bias towards those, let's say, reputed groups, then you are sort of weighting less on those novel discoveries from unknown views.
Yeah, but I'm doing that out of a triage perspective, whereas I previously didn't necessarily have to do that, and there could be more of a chance to discover somebody that I wouldn't have otherwise known about.
Yeah, I guess the challenge will be how do you get to the silver results published by those less reputed groups of people? That part is really challenging.
Absolutely. I feel like all of us can develop heuristics to get around this problem, and I don't think we will also give the silver bullet that solves everyone's problem. But there's different incarnations of this problem, and trying to address them in different ways to kind of make our lives a little better. So yeah, I think you already mentioned some of the things that I'm going to talk about. We'll see if some are missing. Right. So the problem is much more severe when you're starting to learn something new. Whether you're new to research or not, there is always going to be some topic that you develop a new interest in, and it becomes especially hard to find which papers to read there. Yeah, missing references is something that I guess some of us are burnt by before. So if we can have a way to improve our drafts and cover more of the literature that are relevant, that would be useful. New work published in your own topic, so this is actually the first one and something that you already mentioned. Yeah, and also when you think about an individual paper and whether you want to spend 10 minutes reading it or 1 hour reading it, many papers, we just want to scan it very quickly. And if we can do this in a minute, that's much better than doing it in 10 minutes. So that's another thing that we're trying to do in Transcoder. And like you mentioned, Twitter now is a different source of learning about the literature, and there are other sources like blogs and videos. And it would be nice if we can put all these things in the same place so that you don't have to go all over the internet to find them. And then drawing connections between papers, because not obvious really, like the same topic would be scattered in multiple pages. So these are all like different things that we're trying to address in ScienceScholar. So what is ScienceScholar? Why did the Allen Institute decide to invest in this direction? What's the scale and the tools and the lessons that we learned? This is what I'm going to talk about next. So, like we all agree, this is a real problem. We need to have new tools to cope with this rapid growth, and it's not really clear which tools are most needed. So we wanted to, instead of coming up with like one tool to kind of solve the problem, we wanted to develop. Our strategy was to build a familiar experience that everyone already uses. So we built a search engine in order to acquire a significant user base. And then we can study what their behavior and interact with them to learn better how to address this problem differently. And once we have this platform, we can test new tools or new solutions and monitor their usage. So that's kind of what we've been doing over the past 3 years. Today, I like to think of ScienceScholar.org as a faster way to read papers. So if you're really going to understand the paper very thoroughly because you're going to re-implement it, it doesn't matter. You don't need really ScienceScholar for this. You need to get a PDF file and read it. But most of the time, I'm reading the papers very quickly, and I want to get the gist of it. Another thing that I think about when I think about ScienceScholar is how to draw connections between different papers. So how does this paper talk about that paper? Instead of going all over the PDF, ScienceScholar can help me do this. Most importantly, ScienceScholar is a way for testing new ideas in this space. So what I really liked about this project is, unlike many of the research teams, I have a way of evaluating what I do with a real user base. So today we have 40 million papers in the corpus in computer science and medical domains, and this much topics and mentions in the papers and relationships we extracted between them. And the user base is around 2 million unique users every month. They're scattered over the globe. We're very happy to see uptake in different countries. It seems to just correspond naturally to where science is being done. This is going to be, I'm not sure to what extent you're interested in it, but I'm going to go over it quickly to kind of give you a sense of how we're enabling this website. So there is a web crawler that goes in the internet and finds all sorts of papers that look like PDFs that look like papers. We also make contracts with publishers like Springer and Science to get the PDF files from them. We're not allowed to serve the PDF files, but we're allowed to mine them and understand what's in it. And then we have things like PubMed and DBLP, just like catalogs of publications that we also ingest. And then all this goes through a junk filter. We try to cluster together papers that look the same. So because the same paper may be put on your one draft of it on your website, but another one published by the actual journal. And then we create the connection, the citation graph. So we extract, sometimes this is already provided by the publisher. Sometimes we have to get it from the PDF file, put it all together. We run our machine learning models to extract figures, entities, and other kinds of metadata. And then we create the search index. We also put some of the data in a database so that we can enable some of the features on the website in a more responsive way. I think that's the gist of it.
So if you, just out of curiosity, I mean, so one thing I sometimes look for is if a paper is maybe participating in a shared task, if they do very well, maybe you meet Stanford, Berkeley, and CMU, and that will certainly get my attention. So do you look specifically for shared tasks that papers might participate in and say, we're doing this much better?
not yet, but this is, so we're doing like one aspect of this, which is finding the quantitative results that are mentioned in the paper and highlighting it in the page. But this is not going all the way to understand this is like a state of the art result. But this is definitely something that we would like to work on. There's just like so many things that needs to be done.
Are you getting tables? I didn't notice those explicitly mentioned. Maybe that's in the heads.
Yeah, so we did, so we extract the tables, and I worked on a project which tries to give in a data set name, something, and grounded in a paper that talks about this data set, find all papers that provide, like, that publish results on this, and try to merge the results in one, kind of, to create a leaderboard. It's very difficult. The biggest problem there is that we don't have good training data, and creating just an evaluation set was very expensive. So yeah, it's like we can't hire any person who didn't work on this domain in order to do this job. So yeah, we did it ourselves. Like of course, the evaluation set was pretty small, and we stopped working on this problem for that reason. But yeah, it's definitely one of the things that we're very interested in and we'd like to invest in forward. This is how we integrate our machine learning models. So we have every model is hosted on a Docker container. It's hosted on an auto-scaling group. So this means if today we ingest 10,000 additional papers, we want to spend more Docker containers in order to run the model on more papers at the same time. But most of the time, it will only be like one Docker instance running at a time. And then the output of these models is stored and versioned in a database. I think I'm gonna skip the demos. Maybe just like in case anyone didn't try ScienceColor before, this is one of the more interesting features in ScienceColor. So when you go to a paper, you can go to the references and find out how this paper talked about that other paper, which I often would like to know when they think about the connection between, yeah, I know that they referenced this paper, but what did they say about it? And I could go like fish for this information, but it would be nice to have it already presented somewhere. And then there are things like tutorials or blog posts that we find on the internet and link it to this paper. We extract the figures and tables. And it's a surprising number of users, once they look at the figures, this is all they care about, and then they go away. And that's, I mean, I understand. Like, you know this work, you just want to know if they beat the results or not. That's something like this.
But as I said, if this is a standard set, and if they really do well, then
I'm going to delve deeper. Yeah.
And this is certainly going to be maybe interesting, even if the author's not as well. So I think there's some justification.
No, I agree. I mean, and honestly, the way we evaluate things is whatever the user behaves, like we don't think of ourselves as like the people who know how research should be done. And like if you have this feature and they don't use it, they're so stupid, right? No, it's the other way around. If we invested 6 months developing this feature and nobody used it, we were misguided. We had false assumptions about how people do research. So whatever people use is the right thing that we should be developing. Of course, this is a slippery slope because sometimes there's an incentive that you, like, for example, if you're an author and we like inflate the number of citations that you get, maybe you'll like us more. And so I think we need to monitor our transparency for this to work. And this is something that we take very seriously.
So the table is actually extracted like a figure, right? It's not parsed tables. If somebody wants to search, let's say, blue, and the table that you showed me is actually a figure over there. So that's the search work. My other question is, PDF is probably the most unfortunate format for working with this kind of stuff. It was created for printing, not for parsing and building a search engine out of it. What other problems you face? Like table is definitely one of the things. Parser, I don't think there's any good enough parser where you give a table and get all the rows and columns extracted properly. But in case if you found any good parser, I would like to know.
So we tried about 5 different parsers specifically for table because of the project that I mentioned before. The best one that we found was OmniPage. It's you have to buy a license to use it, but it does a good job. Like out of the box, it gives you something like 70% full table accuracy. Like the tables will be exactly correct. And we did like a bunch of heuristics on top of it to kind of improve some of the mistakes, like merging and splitting different columns and rows, and we get it up to like 92% on our evaluation set.
Okay, so that table is also indexed, even though you're showing it here as a figure, the numbers in that table is actually indexed in your.
We have this information, but it's not on the web, right? So it's like it was done in a research project that we stopped serving. But yeah, it's yeah. I mean, I also can't share the outputs. Like for licensing, it's strange licensing issues. We can't really put out the tables extracted with that product. It's kind of bizarre, but this is yeah. We have to abide by the law.
You didn't mention archive specifically there. Is archive included? Or?
Yes. Oh,
Okay,
yeah.
so it's not like you're specifically.
No, archive is a special thing, right? Because it's good with LaTeX, right? So a lot of papers there also have the LaTeX file. So this enabled us in some cases to provide supervision. Like for example, the figure extraction model that we have, we don't want to sit down and annotate a whole bunch of like boxes around the figures. So instead, we can modify. So what we did here was we injected a change in the LaTeX file so that it's every rendered PDF will have a red box around the figure and around every table, and then we can automatically learn a model that knows how to find this. So this is our supervision. But then also like the format is different from things that are built with LaTeX, so we needed to do it with other things. So you can do the same thing in other things like XML papers. But yeah, it's a very rich source, and we have a good relationship with Archive. So we also use our APIs, as I'll mention later, to kind of enrich the features on their website.
No, those new boxes with the like sliders. Is that semantic style?
The one I was referring to is showing the references and so what papers are referenced and what papers cited this paper. Okay, so going back to the slide. So in addition to the website, we also provide some resources in case you're interested in this domain. So we have a corpus of about 40 million papers. Of course, the level of detail we have depends on the license we have for that paper. For some of them, we have abstract. We never provide the full text for the papers, but most of them have abstracts, and most of them have the citations mentioned in the paper, and also the entities that we extract from them. The next one is the data set of peer reviews. This took a lot of work. It's kind of a consolidation of efforts between talking to program chairs who are willing to let the reviewers and the authors opt in for the reviews, and also collecting things like open review in order to put together a data set so that you can study the reviews and how the process happens. And then the next one is a REST API, which anyone can use to look at papers and authors. Like I said, Archive uses this now. We have a paper parser, so if you have a PDF for a publication, you can use our parser to find the title, and it's basically the same code that we use in production. And there's a couple versions of them. What we actually do is we run both of them and we merge the results.
For the peer reviews, do you have some statistics on it? Which venues do you have them, or which domains?
Yeah, so the paper has a lot of this information. I can.
Well, if you don't have it, don't worry.
No, I have it in a slide somewhere. Well, I guess this doesn't have the information. So I can tell you that it has a lot of NEPS papers. It has a lot of archive papers. Sorry, archive was only. So we did this thing where we assumed that papers that were submitted to archive around the submission time of a conference, and then in the same area, and then they were later didn't show on the proceedings. We marked them as likely rejected. But yeah, there are like a few of these things that we put together in the data set.
So do you also continuously update the citation count from maybe other data sources? Let's say you passed the paper and indexed it this month, and 3 months later, the citation count will be out of sync. How often?
The citation count?
Yeah.
What happened to it?
So there will be more citations.
Yeah.
In your database, it might not be updated.
Oh, no,
how often do you update?
we keep updating. So because we always ingest, there's some delay, of course, right? So even things like archive, I think we do it like every 2 days or something like this. So yeah, there's gonna be some delay before the numbers are updated, but our goal is to be able to update all our statistics in 2 days once the paper is provided by the source.
Okay, so what about the entity parsing and relationship parsing? Once you extract the text, what is the NLP pipeline? Figuring out the entities and stuff like that.
So I'm going to talk about this in the next section of the talk.
Okay.
All right. So and yeah, like I said, some of the other external collaborators decided to use our tools for their own work. So some of the things that we learned from our users. First, how we learn from our users, right? So there are 4 main ways we do this. One is basically asking them for feedback, and we get about like 100 comments every month, every week, and we have someone who's it's a part-time job to analyze them and respond to them and take action to reflect what we were told. Some of them are of course like, oh, you're doing a great job, thank you for doing this service. But also, a lot of them are like, you completely messed up my author profile, right? That's this is one of the biggest problems we have with our disambiguation. Even though we did progress on it, it's still a problem, and it's really a problem with all the existing resources. So if you didn't curate your own profile in Google Scholar, we compare to those profiles and we do better than them. But yeah, of course, customizing the profiles is the best way to go. So we're also doing this, but it's going a little slower than I would like. And then user studies is a different way. So if we have a specific question that we would like to ask, like, do you care about this more or this more? We find a group of users who represent a profile that we're looking at, and we ask them specific questions. We do E/B testing for all the major changes that we do, including new features, to see whether people are using them or not, and we define some metrics for what we consider to be success criteria. And finally, we look at things like, how do people reach our website? How much time the user spend on topic pages as opposed to the paper detail page, to help us make decisions about what's the next thing that we should be working on. And for some of the actual lessons that we learned, so computer science users turned out to like external content much more than biomedical users. So biomedical thought adding Twitter is a very immature thing to do in scientific, but as we see, like in our domain, actually it's a legitimate way to learn more about this area. Again, it has its downsides, but this is one of the differences. Another difference we found that biomedical users actually would like us to develop a natural language interface where they can ask questions like, find papers written by Jonathan May and about machine learning. But CS people don't trust, I think.
Select star where author.
Right. Yeah. I think we'll just like more comfortable writing queries, formal language, right? But yeah, there are other interesting things like we found that. I think this is not a surprising thing. Like among all the things, the problems that we talked about, being able to stay up to date in your own research topic is the top priority for pretty much everyone. And yeah, some of the most wanted experiences is a way to read the papers faster. So this includes things like extracting the tables, the figures, and the entities that are discussed in them, and also finding relevant papers. Okay, I'm going to talk about the difference as I experience it between industry research and academic research, because I think it's an interesting thing, especially for students who are here, I guess. I don't know. Because it's like a decision that one needs to make, right? Do you want to work in an academic group or a research, on an industry group? And of course, there are like places that blur the lines, and I think I is one of them, actually.
I was going to say, what is AI2?
AI2, I consider it to be a mix. Some people do industrial research, including myself, and some people do more of academic research. But yeah, I mean, in pretty much any CS research project, you identify a research problem that you care about, you develop a hypothesis, you make some assumptions and implement solutions and evaluate them. And you repeat this however many times until you're happy with the results and you publish it. In industry, you also need to have a platform where you can use this, like integrate the solution and finally integrate it. And publishing becomes less of an important consideration, but it depends on the person's priorities. If a researcher wants to maintain a strong academic publication record, that's an important thing for them. When you think about the key distinctions, or the way I think about them, one of them is how the research translates into real-world impact. I think most of the academic research work that we do, we hope that it will have a big impact, but very rarely it does, because there's so many papers. The assumptions we make tend to be pretty strange. So by having this relationship with a product team who actually are committed to take the output of your research and integrate it, you make sure that your research will translate into real-world impact. So this is something I find to be very appealing. Another thing is, oftentimes when we do research, if the ideas that you have don't translate into improvements on top of the state-of-the-art or a strong baseline, that means the project was a failure. In industry research, this is not necessarily the case. We still got a state-of-the-art system for doing relation extraction, and that's a great outcome. We can integrate it, and we can have the best model on Earth, right? This is a good thing. It's necessary to make reasonable assumptions, like I said before. Data collection turns out to be not an optional thing. You have to do it because the existing data sets very rarely align with what you care about. Yeah, and like we didn't actually do this just yet, but I hope we will going forward to actually use the involvement, whether it's implicit or explicit feedback from users, to improve our model. And then, yeah, basically in Internet Explorer, I try to align the research, the problems that we do, so that it has both impact on research and also on product. But when it comes to the decision that we make on a day-to-day basis, we have to decide whether we want to prioritize solving the problem for this data set or for that data set. Yeah, because this tends to make some difference. All right, so I'm going now to talk about the actual research that we do. So the way I think about analyzing scientific literature, it's a useful analogy I found is to think of a paper as a city. So you can explore a city by going around its street and looking at its landmarks. So you can do the same with a paper, but also you can look at how it's connected to other cities that are related to it. So this is how you can go from Seattle to Portland, and like you can ask what are the related or the closest cities to Seattle, what are the ones that has similar demographics. Again, you can do the same with papers or different artifacts in the literature. And finally, you can try to understand at a global scale for all papers or for all cities that have a specific characteristic that are coastal, right? That have a large representation of African Americans. What does this mean for some outcome variables that you're interested in? Again, we can do the same with this corpus. These are the three directions that we took in our team, and they're complementary. So doing one helps you do the other. So focusing on the first one first, we extract figures, we extract tables, entities, and relationships between them. We started recently like promoting this problem or project called paper FAQs. There are some questions people often ask about papers, and we would like to have a good question answering system or sentence classification system, however you would like to think about it, that gives you the answer to these questions for when they're there for the paper. And the first one that we tried was quantitative results. So each of these has a model behind it that we have to collect a training set for, evaluate. There's a lot of work that goes behind each of these structures. And in interest of time, I'm going to skip. So this is how it's represented on the website, right? So we have features. So here, this is how we show the quantitative results when the paper has it in text. This is how we show the figures and tables. We created topic pages. So if you care about neural machine translation, we have like a page for it where you can find by some metrics the most important papers for that domain. Now, this is something that I think should be customized, and we're working on this. But right now, this is a static definition. There's a query that we defined that kind of finds the most important papers for this topic. Yeah, and then we show some connections between the papers. I'm going to skip the model description in the interest of time. And so this is the second direction. Oh, please.
It's okay. I was just about to ask for the entity and relation extraction. Do you have to also customize it for domains? So do you have a definition of what type of entities you are interested and what type of relation they can hold? I would assume it will be different from domain to domain.
For entity and relation extraction, we found that it's necessary.
Okay.
Also for things like figure extraction and table, we also found that it's important to tune the model, to have two different models, one for CS and one for climate.
Oh, I see. And then do you have your own taxonomy on each domain, or you inherit it from somewhere, or?
So we ground all the entities in a knowledge base. So in CS, we use a subset of Wikipedia.
Okay.
Of course, the problem with this is coverage. And in biomedical domain, we use UMLS, which is a meta-thesaurus of many ontologies. So I'm okay with this in the biomedical domain. I'm not very happy with it in Wikipedia. So one thing that I'm currently working on with a student from CMU is how to extract new concepts that are not mentioned in any knowledge base and augment the knowledge base with it. So you can think of it as knowledge base completion, except not adding relationships, adding actual.
Interesting.
It's surprising that, like with all the work that we do in knowledge-based completion, there's not enough work on actually finding the entities themselves. Okay, so now let's zoom out a little bit and think about this paper in context. So a paper is written by an author. The paper cites other papers, which may or may not be written by the same author. So one of the problems that crop here is, well, two of the problems. One is finding what are the list of references in the paper. So we treat this as an RNN, as a sequence labeling problem. We need to find for every segment in the paper, for every token sequence, whether it corresponds to a reference or not, and if it does, what's the title, what's the author names, and then after this, the matching to another paper for which we already have metadata becomes trivial, and then we need to find author, like whether the different author names that look similar are really the same author or not, which is, I would say, the hardest problem that we have. And then we extract the entities, as I mentioned before. Those entities, another thing that we're interested in, so we develop models now that try to reason about each citation and what it means. So we currently have 4 types of citations, whether this is comparing a result, whether this is building on the same methodology, and whether it's just like describing this as part of the background for this paper or like the setup for the paper, and another category. There are so many, like actually there are a fair number of classifications for how citations should be classified, and we were not happy with anything. And there's not enough data actually for most of the classifications. So most of the classifications are people who put a theory for how the citations work, but didn't bother to annotate any data for it. So the next problem is trying to find the missing citations. So oftentimes when we write a draft, there are missing citations that may result in the paper being rejected. So we developed this tool called Cytomatic so that you can upload a draft and find the missing citations. The code is there, so you can build it online, build it locally as well, and run it for your papers. Another problem that we have is ontology matching. So because we want to make sure that the entities are grounded, we need to deduplicate across the different knowledge bases that we extract, that we link to. And it's a very important problem, but not enough work has been put in it, at least in the NLP literature. There is a decent amount of work on it and the data integration from the database community. But yeah, we tried some of these things, they don't work really well. We have a neural model that does this better than the baseline. And we're planning to continue working with this. Like I said before, we try to also mine our own knowledge base from the concepts and their definitions as described in a paper. And we can do this in a nice way because we already have a decent number of entities with their definitions. So we can look for those definitions in papers and start learning the language of how people describe these concepts in papers. So hopefully this will be an actual submission in a few weeks. All right, so the third direction is macro analysis. So zooming out a little further, we can look at all papers that report clinical trials, let's say on the kidney diseases, and try to extract the number of males and females that were participating in this study. This way we can have a scalable solution that answers questions about bias in demographic participation in those clinical trials. And this is important because the results that you draw from the clinical results are often tied to this demographic. And the treatments that work well for one demographic may not work well for others. Another problem that we worked on is trying to understand the association between pre-publishing papers on arXiv and having citations. So these are interesting questions that we need to make a practical decision about whether we want to pre-publish or not. And what we found was you get 65% additional citations associated with papers that are pre-published. And this is only studying papers that were published at the same set of venues. So we try to account for some of the confounds, like who are the authors and what's their H-index, things like this. And this seems to be still like an important feature. These are some of the papers, so I'm going to share the slides in case anyone would like to delve deeper in any of the things that I talked about. I try to be very high level. And yeah, so I'm going to talk a little bit about some of the opportunities that I would love if anyone here is interested in working on these. So I'm happy to talk in more detail. The first one, which I think is very, like you said, would be very useful if we're able to find papers that give you the best results on this task that I care about. So as a prerequisite to this, I think, because we worked on this a little bit, and the biggest problem that we had was, beyond the data, is that we are unable to understand what the table content means. We were trying to just do text matching, is to have a better understanding of what the different cells correspond to. Are these different methods? Are these data sets? So this is one thing that we need to do. And the problem transforms slightly from one domain to another. So we need to have also a classifier that says, what kind of table is this? Is this showing examples of the output of your model, or is this comparing the demographics in a clinical trial? So I think it's a very rich problem to work on, and it's very understood. Another one is document level salience. So oftentimes in NLP, we work at the sentence level to extract entities and relations from individual sentences. But often the sentences belong to a larger discourse, and in many cases, you care about the larger context more than in any individual sentence. So how can we translate what it means for all the models that we work on when we think about in the document level? I think salience is an important thing that's very understudied. People only study it really in NLP in summarization context, which is useful, of course, but it's not the only place where salience belongs. Another problem is author disambiguation. Again, it's something that people have worked on a little bit, but for many years it's not been studied, and it didn't really benefit from all the advances that we have in neural models recently. Again, the author disambiguation is a place where the data is still an issue. The existing data sets are fairly small. they're biased in strange ways. So I'm hoping that we will build a larger data set for this because we care about it a lot. But yeah, it's still work in progress. And then crowdsourcing annotations. I think this is important for many domains, not just for scientific documents. Crowdsourcing is seen as a savior in many NLP applications, but it only really works when you care about news or reading text that can be understood by the crowd worker. So how can we solve this problem when we care about scientific documents, when we care about legal documents? This is something I think that if we know how to solve it, this will have huge impact. There are more macro analysis projects that we can do, so we can study things like what makes a paper more impactful. How do scientific communities evolve over time, right? So this year, AKBC is becoming its own conference. Every couple of years, you find a new conference in computer science. What is the threshold at which we decide as a community this is worth fitting out as a separate thing? And sometimes those conferences end up being actually very important, like EMLP, and sometimes they don't, right? So how can we characterize this decision and say whether it was maybe we just as a community or someone in the community was very passionate about it, but they were misguided. There was not enough momentum in this direction that deserves its own conference. So I would like us to do a better job understanding this trend. Automatic moderation of paper submissions. So arXiv gets a ton of submissions, and many of them are not real scientific. So there are some people who like to generate automatically papers and submit into arXiv. So we can build adversarial system that tries to find out these. And even in Cement Scholar or Google Scholar, you'll find papers that people put on their profile or their homepages because I don't know, it's a work in progress draft or their thesis proposal or something like this, and we would ingest it as if it's a paper. And it's they really look like papers, right? So we need to have a better way of doing this. And again, this is a problem that nobody really worked on this before, as far as I know. And finally, something that will have a lot of impact is doing meta-analysis. So many clinical trials were done on any given disease and with the same treatment. So how can we make conclusions about that treatment in light of all these studies? So this is something that people do in the medical domain, and it takes a huge amount of effort. And I don't think we should aim at automating it completely, but at least we can identify the pain points that make this difficult and work in a semi-automated way to do it. And there's some progress in this direction. So Byron Wallace created a data set that identifies for a given paper what's the participation, what's the problem that's being studied, what's the outcome variable that you're trying to study. So these are all steps in this direction, and I think there's much more to be done. I think that's it. Thank you again for being here.
The danger of sounding you part of action. And because I'm assuming there'll be a lot of people who regularly use your website, and they would not be just they would most probably be part of the scientific community, and they would have probably a valuable vote if they could on what papers matter to them, and kind of harnessing that data. Because even the comment about Twitter being useful is because there are people like that using that network, and they are upvoting something. So is that something that Alan and I or Semantic Scholar is looking at?
So we discussed this many times. So there's a product team in Semantic Scholar whose responsibility is to decide which features we want to integrate. And then there's a research team that I work on, which decides which research programs to work on, right? So I don't decide these things, but at the same time, and I see, we discuss often the pros and cons of doing it. We see things like ResearchGate, which really thinks of the website as a social network, and we're not very happy with how the product is evolving. So we don't think this is and it's a good, like, we're very happy in this case that we were able to see the results of other people who took this direction. But at the same time, I definitely sympathize with what we can gain from this. I would love to learn what other people have to say about those papers. And yeah, I think the short answer is we're not planning to do this anytime soon, but we definitely consider it every now and then.
So you mentioned about the document level problem. I do have a student, actually, he's on BlueJeans. He's working on some problem on document level classification and also some sort of sentence level sequence tagging. I'm wondering, do you have any concrete problem for these, like document level?
You mean an application?
Yes.
So so when you think about entity extraction, and displaying the entities that we extracted from a paper, we find that many of the entities we extract, even though they are correct extraction, they're not what the paper is about.
I see.
So the task in this case is showing, is finding what are the most salient entities in a paper.
Oh, I see.
It's hard to evaluate this without a product, of course. So that's, yeah. But we're working on a data set. So once we have the data set, you'll be able to use it.
Oh, I see. So you will have a data set where you have document level salient entity annotation, and then okay, that sounds good.
So many cases, I think it's a lot of arguments about what is the good scheme for entities and relations when we are creating a knowledge graph or like using them to index the documents in your system. Like, what's your take on this? Like, how did you what do you think would be a good way for semantic scholar to find out a good not perfect but definitely a good enough taxonomies for entities and relations?
So what we did was different in the two domains that we considered. In computer science, it was a lot of iterative work with us, a group of us looking at the data that we get from Wikipedia using different categories, looking at the different depths. When you consider, it was a lot of manual effort. I wouldn't want to do it for every domain. In medical domain, we relied primarily on an existing knowledge base, so we didn't.
I think life science is a little bit better. They already efforts like on MASH, on every like disease ontologies, gene ontology, those kind of things. But computer science, you have the ACM ontology, but some people may not agree with that.
It's not really good. Like we tried using that.
But I heard that they spend I don't know how much millions on creating this ACM ontology.
I mean, it's probably useful for some things, but we found that it's not the right thing for us to use. Like thinking about how this feature will manifest on the website, we didn't think those are the right levels.
So do you work with these ontologists to really think about what is the good design?
Yeah, I mean, like I said, it's a lot of manual revisions of the hierarchy. Like, and of course, there is like a threshold. We can't review each entity. We have to work at the higher level of the taxonomy to make decisions about it. We can't go over each of them. Okay. And yeah, so I guess the short answer is we don't have a really good solution for yet.
Still open.
Yeah, if you have any thoughts, I'd love to.
Don't have this thought.
That's the point.
The effect of preprinting on the citations was very amazing, 65%. Did you consider open accessing the paper, or that had a confounding effect, or?
Oh yeah, absolutely. So we didn't. Other previous studies did an evaluation of to what extent open access had results in larger participation, and they didn't find that the paper being open access, with all the other confounds that they included in the study, you didn't see a significant impact for having the paper in
open access.
Yeah. I should be careful. We cannot make any claims about causality here. We're not. Yeah, I have my kind of intuition about that, but I can't really say that we concluded the causality of republishing two more citations.
So I want to be a little adversarial. That's all right. So it seems, I think this is really great work, and it threatens / enables, more ease, right? Like it seems like part of what you're talking about is trying to make my life as a researcher easier, right? It's easy to find what other, what works I should be comparing to know whether my work is good enough to start publishing. I can just like let the Cytomatic figure out what citations I need to include. So part of me wonders, well, should we be doing that? I mean, this is just going to make the problem harder, right? It's going to make more submissions. And it's gonna, it's gonna remove the gauntlet. Which I'm not just trying to be flip here. Actually, there is a bit of a necessary effort that I think should be undertaken by a researcher in order to do the research, and by providing a comprehensive understanding of the references that you create yourself shows that you actually understand what you're working on,
Right.
and not like just letting the computer do it for you. Now, that being said, we could also take this further, which you seem to resist against, right? So you said you wanted to do archive reviewing to stop automatically generated papers from getting in. And my question is why? I mean, you've already kind of partially automatically written the related work section. Why don't we automatically write the whole thing? Because in a sense, the paper itself is this weird artifact that we're like forcing upon this poor grad student who maybe, didn't want to become an author, right? They just want to do research and show their research. And unfortunately, we have this weird antiquated system that for historical reasons is about presenting papers where the literature of the paper is totally not relevant to us. I mean, it can be, but that's not what we're looking for, right? We're looking for an understanding of the meanings. And as long as I can write down the computer program, let something else auto-generate it into natural language to satisfy the bean counters at the university. So I guess the overall question is where do you think we should be, and why does it seem like we're at this weird intermediate state where part of the work we can automate but part we can't?
Yeah, that's a great point. I don't think I have a good answer to this. I think we're trying. Whenever I think about how to prioritize the work we're doing, I think about the users that we're serving and how they would like us to help them. I try not to come up with a theory of how the world should run, because I don't think the theories that I will come up with will be necessarily better than what we currently have, and it will take probably more effort than I can put in order to enforce those theories, right? So just by working with conference chairs for a few years to collect these peer reviews, I understood how hard it is to change the status quo, right? So I feel like we need to find this sweet spot between moving fast and enabling new technologies without dedicating the bulk of our efforts to convincing other people that what we're doing is useful. So of course it's part of this is part of I had to do this in order to put together the data set, but I don't want to spend most of my time doing this.
What do you think would be the ideal outcome for how a graduate student writes a paper in 10 years?
So I definitely don't think the current way. So I definitely don't want us to continue. Let's say that I control the science and sciences, right? I definitely find the way that we currently run, if you don't publish, you're not a good researcher, is causing a lot of this problem. Like I said, I do think that many of the papers that are published are not worthy of publishing, and they're just there because people need to publish. So I definitely find it better if there's an alternative way to evaluate progress for a student, right? And this can be in terms of evaluation, we have already shared tasks. Maybe if a student performs well on this shared task, they don't need to write as many papers. I don't know. I think that would be an important thing going forward to avoid this inflation. I don't know really what is the right metric, but there are going to be multiple metrics to accommodate different types of contributions.
Okay.
And then for more senior researchers, I think there's already less burden to publish. I definitely don't feel as as yeah, I definitely don't feel like I need to publish all the time. And even though like even when I was a student, I felt like it's important to wait until I have a significant contribution in order to publish. I always had this anxiety of like, what if I'm not publishing enough? And especially because our field has a good practical side to it. I think any researcher who does well in our area is able to find a good job, even at a good research. Maybe as a research engineer, but definitely the burden is much less pronounced.
You had a pretty good markers of papers there, though, at the end.
This was so this set of slides was meant to was adapted from an annual thing that we do at the IT. That's why it was there. And I agree. That's still part of it.
So sorry, that's like the percentage of papers that you suggest they are not worthy of being published, but they get published anyway because like there's this need to have a certain number of papers. So do you have any classifications of those papers of what's the problem that they are not worthy of being published? Is it that they are just working on the wrong problem and they are just putting effort in a wrong problem just to get it published, just to have a paper? Is it that it's not the wrong problem, but many other people are like more known names on that problem and they are doing a better work? Like, what is going wrong there that makes the paper not publishable?
I think it's all of the above, honestly. I think it depends on the paper. And the way I think about it is not because I see a problem with the paper, it's rather because I see how the paper was used later. That's where I'm characterizing this. I find a pretty large number of, I don't have the numbers, but anecdotally, I see many papers when I look at our corpus that have 0 citation. And I have one paper that has 0 citation, and I feel terrible about it. I wish I didn't spend this much time working on a paper that nobody cited, because I think citation corresponds to some degree to how other people found it useful. And yeah, it's just like, regardless of how good the contribution I think is, right? Nobody actually cared about it enough. Maybe if someone implemented this paper in their system, that would definitely be useful, but the chances of this happening is much lower than the chances of someone citing a paper. So yeah, I do think many papers are good, but other people did similar work and they're more famous, so that this paper didn't get cited. So yeah, so I think there are many problems that we all know about the way we do research, including replication, including the fairness that result in this situation.
Thanks.
Right, thank you very much.
I mean, I have a clock now that I set it up like